We'll start with argument list, right? So Python allows variable length argument list. Right? Let me show you how it works. Variable length argument list. Right? As always, we can begin with the interpreter information. This is the interpreter for Python code. It could be any function name. I said let's say main, tuple with 5 data set, right? A, B, C, D, E, let's say, and I created one function called XYZ. I pass this tuple called X, right? Now I am passing 5 arguments. So variable length argument list asterisk args. This means n number of arguments can come. So very first thing that programmer does is it calculates the length of arguments. Therefore they can go into each and every argument and let's say print them, right? And now we know else can come with while, can come with if, can come with for. Here I can say let's say a default value, right? Now to execute this I have to run the main function. So this is how I can execute the main function. Right? And it prints me the entire tuple A, B, C, D, E, F, E. But point is variable length argument list. So in the coming classes, whenever you see this, it basically means any number of arguments can come in a sequence. Right? Just give me a second. Right? That was the point, that variable length argument list, and this is how it is being calculated. When we will start the libraries also, I'm going to do the same thing. Now there is something known as keyword arguments, right? Keyword arguments are like list arguments only, just that keyword arguments are there for dictionaries instead of tuples. So KWARGS, right? Keyword arguments, KWARGS. Let's say that is a file name. When you have to work with dictionary instead of tuple, so I can create again, this is my interpreter, right? This is my interpreter, and this is, now to understand keyword arguments, right? Dictionary, DICT, right? Dictionary with key value pair combination. Let's say small animals, or let's focus on the a value x key value pair combination. Right? B is equal to y and z is equal to, or c is equal to z. This is our dictionary, right? And how to pass this keyword arguments? So I called another method called PQR double asterisk x. Remember in the previous example I wrote simple. Dictionary is represented like this, right? So this is my function PQR keyword arguments, right? If length keyword arguments, same thing I am doing for each and every element in keyword arguments, right? I can print using f string type or simple that variable first one says second one, right? And using format function I can pass both first one, that is key, and keyword arguments associated value for this key, right? Else can come with both for and if and while. Here also I gave a default value, right? So now to run this, again I will call the main function, or it could be any function. We have learned that this is not mandatory, but point is, this is how keyword argument is being written down, right? When I run this, you see here KWARGS, K in square bracket, and closing the brackets properly. Running this, variable a says x, right? So keyword arguments, they are like list arguments which are used for dictionary instead of tuples. Double asterisk ARGS, keyword arguments, it could be any name, but conventionally every programmer uses KWARGS. You can use other keywords also, right? It is not mandatory that this has to be used, right? Keyword arguments. Now function can return any value. So I am creating a class called, let's see what values functions can return. In Python there is no distinction between function and a procedure, right? So again I am starting with the interpreter information. This is the interpreter for my Python code. I can create any function, but let's say I am going ahead with main function only. Main is calling some function called mno. Value I am taking in a x variable. Print, first I am printing the type of x, and then I am printing the value associated with x, right? So definition of MNO, right? Print MNO function called. Alright, now return. If let's say I simply return a value called 42, it will print me class integer and value 42. How can I run this? Let's run the main function. Right, now if I run this, it says MNO function called, print type integer and value 42. If I pass a list, square bracket 43, 44, it will return a list, right, like this. If I want to pass a dictionary, let me just comment this out and let me return a dictionary. Dictionary is returned like this: DICT, X is equal to 42, Y is equal to 43, Z is equal to 44. This is a dictionary. I saved it and I ran this. It says class dictionary and it printed me the type of data. So now we know what return types are, or how return types are predicted. Then comes two important concepts: generators and decorators. Generator is a special class of function which serves as an iterator. Instead of returning a single value, the generator returns a stream of values. Again, I am repeating it. Generator is a special class of function. Instead of returning a single value, generator returns the stream of values, meaning multiple values. Right? This is where my interpreter resides. Main function. For I in the inclusive range. Inclusive meaning I would like to take the last number also into consideration. Inclusive range. Print I. Thereafter delimiter. I can use flush variable also, and to make this end properly, a simple print function. Now you know about variable length argument list also. So as of now I am simply returning one argument. But what if I return more arguments in future? So first thing that I am checking is the length of arguments that I have got. Then I am introducing two variables, start and step, and we are learning generator, a special class of function, right, that returns stream of values. If you give me just one or you don't give me even one argument, how to raise exception? You know, when you don't give me a correct one argument also, I will raise the type error. Right? I will say I was expecting at least one argument and you gave me 0. Right? I can print that argument length itself using f string type. So if you give me one argument, I need to print from 0 to 25. So start is 0, step is 1, and we are talking about generators. So you need to introduce a new variable called stop. Stop is where I need to stop, 25, if you give me just one argument. If you give me two arguments, right, that means you want to give me both start and stop. That I will show you. As of now I am simply passing one argument. So tuple, start, stop. Now you will say generators are always written like this. I'll say yes, always and every time. If you give me three arguments, then I'll say start, stop and step, all three will be placed in these three variable args, right? If you give me more number of arguments, I am introducing type error and I am saying expected at most 3 arguments, whereas you gave us 4 or more than 4. This will work when f string type will come into picture. Now this is fine, but what is a generator? Now the code for generator starts. In every piece of code, stream of values, special class of function. Once you have mentioned how start stop step works, I need to mention how this entire thing will work. Yield I, and this is how generator works. Start value I will go till stop, go through each and every value, and step is this. If I execute main function, a stream of values inclusive range will work. Num args, right, 0 to 25. Generator. This all happened because of this. A stream of values, a special class of function. Instead of 1, 25, if I mention 3 variables, 3 arguments, starting from 5, going till 25, step value is 5. So 5, 10, 15, 20, 25. When I run this, it says 5, 10, 15, 20, 25. So generators, a special class of function that serves as an iterator. Instead of returning a single value, it returns a stream of values. Are generators written like this in every piece of code? Answer is yes. Yield is a sign in, let's say, US, when you have to allow others to go. Here it is allowing others to go. This is how it is processing, right? They have taken the same thing. It's in Java also, it's in thread also, yield function. Then comes decorator. You need to practice this, right? Then comes decorator. Decorator is a form of meta programming. It's a special type of function that returns a wrapper function. How? Let's take an example of a decorator. So I am importing, first of all, user bin env python 3, right? I am importing a module called time, right? I am creating a function called elapsed time. I am saying a function will be given to you, right? And I am creating one wrapper. In Python, time is calculated, my system time is calculated like this. Then whatever function you will give me, I will execute that. Again, I will find the time. Time. Then I will print how much time the function has taken. Using f string type, I said elapsed time, I mean the time taken, t2 minus t1, right, into 1000, and this output will be in milliseconds. But this entire thing will go in a figure bracket because these are variables that are calculated outside. And ultimately this function will return the wrapper, the entire object. We are talking about decorators. Now I am passing this function to another function. Let's say I am having a function called big underscore sum, and I am passing elapsed time, right? I pass this function to another function, right? What I am telling is the entire wrapper functionality is given to big sum. Let's see, num list empty, right? For num in entire range 0 till 10,000, right? Num list dot append, form of meta programming. What am I doing? Going from 0 till 10,000 and I'm appending this 0 to 10,000 in the number list. After appending, I am printing using f string type big sum, right? Sum in the figure bracket. I would like to print this num list. It will calculate sum from 0 to 10,000. A special class of function. Here f string type closed. A special class of function, basically, that returns a wrapper function. Decorator is this. I pass this as a wrapper function to my main function called big sum. Big sum is to calculate numbers from 0 to 10,000. Add. It is going to add. Now I need to run this. So def main function. Main is going to call the big sum. Big sum is going to use the decorator called elapsed time, right? And this is how I am going to run this. I ran this from 0 to 10,000. This is big sum and this is elapsed time. Elapsed time got called automatically. This is how decorator works. Elapsed function wraps the past function in timestamps and prints the elapsed time. It prints the elapsed time after adding the whole lot of numbers together, right? This is how decorator works. Again, you need to practice this, and we are going to adopt similar kind of functionality in the coming sessions also, after we start the libraries and the Django framework, right? Thank you.